This Fleet Equipment Unscripted interview is presented by Hendrickson, a leading manufacturer of heavy-duty suspension systems and components to the global commercial transportation industry. Visit hendrickson-intl.com to learn more.
Hey everyone, Jason Morgan, Content Director for Fleet Equipment. Welcome to Fleet Equipment Unscripted. I'm pretty sure this is the last ACT Expo video I have to bring you. I know, but there's always next year. We've saved a good one for the last one, though. We have Todd Anderson, Vice President and Chief Technology Officer of Phinia, to take us through decarbonization at the component level for internal combustion engines. Take it away, Todd.
All right, Todd, thanks for taking the time. Can you take me through, so the scope of the conversation here at ACT Expo is really widening to include a broad array of decarbonization solutions. Let's start with diesel because it's tried and true. Take me through what you got here in terms of diesel efficiency and improving that.
Oh, sure. Well, at Phinia, we focus on improving efficiencies of our systems today while driving toward a cleaner tomorrow. So, as you mentioned, diesel is one of our traditional systems, and we've taken some time to innovate in commercial vehicle diesel activities that improve efficiencies. We've seen some customers getting as much as 10% fuel economy improvement.
Oh goodness.
Not only attributed to the fuel system, but the fuel system is part of those fuel economy improvements.
I see.
So as we move toward decarbonization, whether it's our closed loop diesel injector or some of our different pump systems that we can do for high pressure fuel pumps, and then all connected through the common rail, these are activities that we do in order to drive improvements today. Now, it's going to take the best of every technology for us to achieve our global decarbonization efforts. There's not a single silver bullet. And we're focused on practical solutions. What steps can we take now today, even if it's not the full end game, to make improvements as we move toward a cleaner tomorrow?
Yeah, for sure. And I think that can kind of get lost in the conversation too, the importance down at the component level. With the components here, is this at the OEM level? Is this aftermarket? How do you see customers interacting with this? So
we supply components all the way up through full turnkey solutions with diesel and gas fuel systems to OEMs as a tier 1 supplier.
Perfect.
We also have a large aftermarket component, and they provide replacement components. If we can keep existing vehicles on the road longer, that contributes to overall sustainability and lifecycle improvement as well.
Right. Well, and operating at that same expected efficiency level, not losing any efficiency.
Correct.
All right, you mentioned gasoline. Let's take a look at what you got here at the booth for that.
Super. So we provide gasoline direct inject systems. Typically what you might see in the industry is a 350 bar pressure or 250 bar pressure. We have those, but we have recently introduced a 500 bar pressure GDI system. We provide the GDI pump for that, and then, for example, this one is a 350 bar but can go up to 500 bar with injectors on a fuel rail assembly, all controlled by an engine control unit that we do the software, system integration, and calibration for many of our customers. So we'll supply at a component level on up to a full turnkey vehicle solution for the fuel system.
Yeah, very good. And we're seeing increased interest in the gasoline application for medium duty as well. So those applications are really going to start to ramp up there in that world.
They are, and a real benefit from our higher pressure is we get better fuel atomization. So fuel economy improves, and in fact the overall system cost can be reduced by reducing some of the filtration requirements to be able to use our 500 bar system.
Very cool. I think you have some natural gas and future fuel solutions here. Let's run through those.
Yes, let's do. Maybe I'll just start right here with some of our alcohol fuels, ethanol at 100%, methanol at 100%. We have customers that are increasingly looking at that for carbon reduction, and we have compatible fuel system components to be able to drive that performance. It's not trivial to be able to take an existing system and run methanol at 100% through it. The corrosivity and the challenges of doing that but our technical team has overcome those challenges and has addressed things of cavitation, material compatibility, durability, and we're seeing a good response for that globally in Brazil with ethanol. And as you mentioned, natural gas, that's another area that we're working on, especially with customers in India, but not only. There's quite a bit of interest in that.
Well, yeah, especially here at the show, natural gas has been a growing talking point. There's a new 15-liter platform that people are kicking the tires on in the fleet world as well.
Yes.
So much to come for there.
Yes. It's interesting because you can get a carbon benefit through a CNG, for example, a compressed natural gas. And what we see some customers doing is taking that compressed natural gas and layering in a proportional amount of hydrogen, say 10% or 15%, for even additional carbon benefit without sacrificing performance characteristics of the fuel system or the engine.
Very cool.
So when we talk about natural gas and some of the fuel system components, we have port fuel injection systems that will do compressed natural gas at different levels of flow, including a high flow. And this is a basis for our hydrogen system as well, because it's injecting a gaseous fuel. And we're leveraging the skills, the competency, and expertise of our design teams to be able to use existing compressed natural gas and transport that or convert that to hydrogen systems also. But we also have direct inject fuel systems to combust hydrogen. It's a great opportunity to be able to get similar power and performance characteristics you might expect in a diesel engine, in an ICE engine, for CNG or hydrogen, but to do it with a fuel that has zero carbon. So we have an injector that looks very similar to our gasoline direct injector, and this has been modified to run on hydrogen. We have vehicles in Europe that are operating currently with direct inject ICE for hydrogen and in getting excellent power and performance. So we see this is a growing interest, especially in areas that might be off-road applications, applications that have high load characteristics or continuous operating cycles that need power and performance and need uptime. Just like I mentioned about we'll need every technology to meet our global decarbonization goals. There are segments that do quite well with EV. But there are segments where EV doesn't really have the characteristics that's needed for the application. And H2 ICE is a great opportunity to be able to provide that.
When you're engineering these new components, how challenging it, or how much can you bring over between all the fuel systems, or do you have to approach them kind of clean sheet as you develop?
We leverage a lot of our background and experience on compressed natural gas, on diesel, on gasoline, and have brought that forward into hydrogen and other alternative fuels. There are definitely some unique characteristics that we have to design for. Hydrogen, for example, can embrittle steels and materials, and to get the life and durability we need to account for that. But there's a lot of existing ICE component and system design that can be used as we move into hydrogen. One of the unique characteristics is the engine mechanization, the combustion strategies that are used, and we have our own software and calibration team for engine control units that will allow us to adapt the engine control for hydrogen from diesel or from gasoline.
On the natural gas side, how will, at the component level, how all have you seen it evolve? You know, natural gas, not a new fuel to the fleet industry, but one that has a new lease on life a little bit now with a new platform. Are those misconceptions or those old experiences fleet might have with it? Is it a different fuel today? How are you viewing the evolution of that usage?
Yeah, interesting. I think some of that is fuel availability and cost that's driving some of that resurgence. Depending on the level of fuel emission system that was being used earlier, some customers may have had some challenges with natural gas, but the customers that are using it now are seeing good performance on our fuel systems of today. So The fuel is the same. The technology, I would say, has evolved a little bit.
Yep.
And we see good performance and good uptake on that.
Very good, Todd. Thanks for taking the time. Appreciate it.
Yes, you're welcome.